All right. This one here, 12, right? Let's see. I think that's right. Yes, 12. So this guy right up here. Whoa. Okay, that was unexpected. What are you doing, Pen? Okay, that was weird. All right. Sorry, I'm easily amused. Yes, there's a chat. Yeah, I'll do that next. So right now I've got problem 12 and 10.2, and then I got a question from 10.3. So this one here. And it says, if possible, solve each triangle for the unknown side. That's all it wants, is the unknown side. So you don't have to completely solve the triangle. Let me see. Blah, blah, blah. Yes, yeah, good. That's always nice to see. If it says solve the triangle, that means completely solve the triangle, find all the answers for all the sides and all the angles. This one just wants angle C. Side C. So I can set this up, make like a generic triangle. I'm going to put beta right here. That's 67 degrees, which means what's going to be here? What's going to be here?
38.
38. It's got to be B across from B. It's crazy how that works. And then I could put A and C wherever the hell I want to. So I'm going to put A there. So that means 49 goes there. And I'm going to put angle C here. And over here, I'm going to put little side C. Okay. So the big giveaway about what to use is the fact that we're in the law of cosine section, right? So I'll bet you almost most of these problems are going to, almost most, Jeff? It's okay. I don't teach none of that grammar stuff. All right. Can I, why, now look at, now to be honest, does it say to use, oh shit, oh good, thank God I didn't clear it. No, it didn't. That's kind of funny. All right. Sorry, give me a second. Notice I don't know angle C and I don't know side C. So if I want to use law of sines, I'd have to use a couple of steps. Will law of cosines work here? So let's remember a law of cosines, and it's kind of nice. The side I want is little c, so it's going to be c squared equals a squared plus b squared. That's Pythagorean so far. Minus, and yes, you do have to memorize this, just in case I didn't say that. Well, it's on your trick sheet as far as what you have to memorize anyway. So I did say that. 2ab cosine big ass C. Do I have everything I need for this formula?
Nope.
Nope, I don't have angle C. Yeah, so no matter what I do, I have to do a couple of steps anyway. So let's see. So then it's really, you could do whatever you want to. I'm not really sure what the point of this is. I'm trying to figure out.
Use the law of sines because I had one complete.
Yes, I love it. And in which case you can find what can you find if you use the law of sines?
I was trying to find angle A.
Good, I love it.
But
so
I got
no matter what. Go ahead, sorry. Go ahead.
But I got a calculator error. So I didn't know if it's just not possible because like on 15, it's kind of the same thing. And you also get a calculator error and it says that the triangle is not possible.
All right, and that's the whole point of this section is some of these are going to be impossible. See if it says if possible. Everybody with me? So it's possible. Let's see. So we've tried to set up law of cosines. Law of cosines is not got enough information to do it. So but we do have a complete ratio we can make for law of sines. So it would be, let's see, I can't remember which way I told you guys. It doesn't matter which one goes where. Equals, and now let's try to find out what angle A is. So if I multiply 49 up, I can immediately see a problem. This is already bigger than 1 here, right? And this, let me see if you guys are cool with this. This is bigger than 1. What's sine of 60? What side is 60 degrees?
Rad 3/2.
All right, so what I'm doing right now, you don't have to do. You just throw this shit in the calculator. It says error, but I can see why it's going to say error. This is bigger than 1 times something else bigger than 1. Can sine of something be bigger than 1?
No.
No, hell no. Sorry, no, that there's no answer. How we doing out there? You guys all right?
Why you say that?
I'm sorry. Somebody made a sound and I made the same sound. You guys okay? Are you guys okay? For real, for serious. Are you guys okay out there? Am I just making 2020 that much more complete? You're like, oh, I took this class and it just belongs in the hellacious year known as 2020. Is that the way? And you're all like, yeah, you think you're being funny, math boy, but you're spot on, buddy. If I knew where you lived. All right. All right. So you're correct. I don't know if I managed to accidentally, you said the same thing happened with number 9 or something else?
15.
Number 15?
Yeah.
That's possible. So yeah, that's possible. Some of those could have been not correct. And the whole point of this is knowing going in that they could set up a triangle that is impossible to work, right? We've seen that before. Okay. I like it. Anything else? Any other questions from? Oh, there was another question. I'm sorry, in the chat. Problems like the ones in the beginning of 10.3. Oh man. Oh boy. Can I just sleep the entire 2021? Is that right? Just, like go full bear mode and just hibernate. I should have done that this year, come to find out. So which ones are you talking about? Talking about these here? Maybe? Can you be a little more specific out there? Here we go. Yes, okay. So the following exercises convert the given polar to Cartesian coordinates with r greater than 0 and 0 between theta between 0 and 2 pi. Blah, 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 blah. Let's try number 8, just for shits and giggles. Let's see what happens. Can somebody, do you guys remember? These hopefully are 2 of the easiest things to remember. What are x and y in terms of polar coordinates?
X is the radius and y is the angle.
No.
It's like r cosine
Oh, never mind. Thinking differently.
something. I don't know.
Yes, cool. And do you guys remember the most basic definition of cosine is the xi divided by the radius, and if you just multiply r up, holy shit. Okay, that's all it is. That is all it is. And you want your mind blown even more? You're like, sure, what the hell, Jeff? If I do y divided by x, isn't that r sine theta over r cosine theta? Don't the r's cancel? Sine over cosine is tangent. Isn't that the other relationship? Ooh, all right. Anyway, sorry, I'm sorry. It really is beautiful, and I don't know if any of you agree with me. But that's the thing about math. It's got to be self-consistent, or else we have to throw it all out. So everything we create must be self-consistent, and so you see that in everywhere. It's kind of nifty. Now that I know this, I just put this stuff in. 6 is r. Theta is negative pi over 4, right? So it'll be 6 times cosine of negative pi over 4. And y is 6 times sine of negative pi over 4. So I will be saying on the quiz, I'll be saying I want exact answers, right? I don't want any freaking decimals. Unless I specify, you can put a decimal, we'll see. Everybody with me? So this is one you should know the exact answer for. Right? What does cosine think about negatives? I'm sorry. Go ahead. Go ahead. Sorry.
Oh no, I said it's rad 2 over 2. The cosine of that.
Because what does cosine think about negatives inside? Doesn't give a shit about them, right? Because cosine's an asshole, remember? So this will be 6 rad 2 over 2. So this is 3 rad. You can do it, Jeff. You can't do it at all, can you? Let's write it all out. There you go, buddy. There you go. Look at that stuff happening. Okay.
Isn't it rad 2 over 2? Because
2. Thank you. All right. I went slower and I still couldn't do it. All right. And then what's going to happen with this guy? What does sine think about negatives inside?
it's going to be negative.
Good. Sine is not an asshole, so it doesn't kill the negative inside. So this will be negative 6 rad 2. Let's see, Jeff. Let's see. You've gotten help from everybody now. Can you do it? Yes. I did it. Oh, what's happening? Can you go over number 54? Is that all right out there? Person that asked me about this? I don't want to call you out. You're private messaging me, so. Okay, and now I got another question, 10-2, number 54. All right, so let me clear this. Ooh, come on, Jeff. You can do it. 10-2, number 54. Here we go. Ooh, I love it. Oh, this is a kick-ass problem. By the way, let's take a look at this problem. Sides of a parallelogram. So draw yourself a nice general parallelogram. 28 centimeters and 40 centimeters. All right, so this is not to scale, so who cares? The measure of the larger angle is 100 degrees. Find the length of the shorter diagonal, right? So you're going to have a long diagonal and you're going to have a short diagonal. Become a short diagonal, okay. So you see when I drew this in, I made some triangles. Yep, I sure did. The thing is, if you're not sure about, how do I want to say this? You can calculate both. I really want to make sure you guys, do you see this triangle right here? Let me trace it out. This triangle, wee-haw, right? Wee-haw. Doesn't it have one of the diagonals as its base? Isn't it side, angle, side? That's law of cosines. Will just eat that up. You can go loco, law of cosines. That works. I like it. Law of cosines. And if you want to calculate this one, well, then this is 28. What would this angle here be, though? If this is, let me see. Let me try this again without all my extra crap in it. Holy shit. Okay, let's try this again. All right, so this was 100 degrees. So what's this?
100.
Huh?
100.
100, good. I like it. So what are these? What are these?
80.
80.
80. I love it. So that you get 360 all together. So if you want to find this diagonal, it'll be 80 degrees with 40 and 28. And then you can find the last side here. Right? So you can use c squared equals a squared plus b squared minus 2ab cosine c, where the two sides are 28 and 40, and then you can use either 80 here or 100 here. Now let me see if I can go further with this. Are you guys okay so far? Are you guys understanding? I've gone too far with this, but this is a bonus. Who gives a shit? Which angle do I put in here, 100 or 80, to give the, what did it want? Which one was it again? 54? To give the shorter diagonal, I want this to be smaller. So you want this piece to be bigger or smaller? If I want this to be, sorry?
Would you want it to be smaller?
Nope, bigger because I'm subtracting it. Do you see that? Ah, good. Everybody good. Maybe. Sorry. It's been a long day. I'm really sorry. I'm going to be a little extra loopy. I'll try. Okay. So which angle will result in cosine being larger?
A smaller angle.
Why do you say that?
Because if you're looking at a unit circle, as the angle gets larger, it gets higher in y and lower in x.
But now I've gone past, right? I've actually gone past the exact same amount.
Oh, gotcha. Because you're at 90 to there, to 100.
Yeah. And cosine, what will cosine of 100 be? It's going to be, it's back here, so it's going to be
It's going to be negative.
negative. All right, that's enough. I've given you enough. Screw it. So you got to consider, you can calculate both, to be honest, and just take the one that's smaller. Do you guys see what I'm saying? It didn't say only calculate the length of the shorter. It said find the length of the shorter. So if on the way you find the longer one, who gives a care? Why not being all careful? Who gives a shit? Who gives a shite? All right, sorry. Anybody else? Any other questions? I have a feeling there's got to be questions that aren't based on bonus. Bonus questions are fine, but remember when it says extensions, if that's the only thing you have trouble with, you are doing perfectly well. Okay, I'm going to clear all this away. All this craziness here. Pop. All right. If there's no more questions, I don't think I missed any chats. No. Okay. Oh. Whoa, something weird just happened. I don't think I missed any chats. What is the chat doing to me? Oh, I see. God. All right. Sorry. So where we left off. So we got the whole polar coordinate stuff, right? Oh, that's before I forget. Do you guys remember I put in here the practice quiz? And I actually did today, a little bit before class, make a solutions video for most of that. So we're going to finish up this practice quiz right now. If I can access anything on my computer, let me see if I can make that happen. There we go. So let me stop sharing here. And let me reshare this. Oh shit, I don't want that. Where are you? There you are, okay. So I'll show you. There's a video that shows all this being worked out, blah, blah, blah. Look at all that beautiful stuff. And then I just didn't do 5. I just got tired and said, I'll do this in class. Okay. Move over. So this is a solve the triangle problem. So you got to solve the entire triangle. And I can't remember if I talked about either one of these. So let's try to do this together. So let's be really, really, really careful about this. Let me do this in a different color too, so it'll stand out. Jeff, stop doing that weird shit over there. Okay. Let's do purple. Let's do freaky purple. There we go. All right. Let's see what Jeff thinks freaky purple is. Whatever. So I can draw a little standard triangle. 42, we'll say this is A here. We got to draw a bigger triangle, Jeff. Sorry. All right, draw. Here we go. That's so much bigger, dude. All right, shut up. So that's 42 degrees. Jeebus, that's A. That makes this 8.1. Let's make this B. So this is 6, and we'll make this C. So this is C. Okay. Now, obviously, which law am I going to use here?
Law of sines.
Yes. Again, somebody beautifully pointed out earlier, it's always when you can make a complete ratio. So I got all the A information. And I can use law of sines to find which angle right now.
Angle B.
Yes, because I have angle B. I have the side across from angle B. I like it. So here's what I always do. Oh, Jeff, you can do it. Well, that's funny. 6 does look like B. So, you know, that kind of works. Let me see if you guys are cool with this. Everybody, you got to be cool with me just multiplying the 6 up. That's bullshit. And then I can take an inverse sine. So I'm just going to do all of that before I throw anything in the calculator. I'm going to throw all of this. There's a 6 sine of life, the universe, and everything over 8.1. Sorry, life, the universe, and everything degrees. So you can throw all that shit in the calculator to let me know what you get.
I got 29.7.
Speed demon. Let me see if I get the same thing. 29.7? Yes.
Yes.
Good Lord. I'm really having trouble. Jeebus. I need more or less booze. All right, let's see. 29.7 degrees. And that's B. What do I have to check? And why do I have to check it?
You have to subtract that from 180 to see if it's a reference angle and if 2 triangles would be possible.
There you go. And why do I have to do that? Why do I sometimes not have to do that? You can say, well, somebody else can do that. I've done my half. Anybody know?
If you subtract it, like for this one, you get 150.3. And so if you would add the 42, it would go over 180. So it wouldn't be a triangle.
But why does that even become a possibility for this kind of problem? I'll give you a hint.
It's an ass.
Yeah, exactly. It's an ass, but more specifically, what's the problem with inverse sine?
Has to be between 1 and -1.
No.
It's because of the range, right? Of
The output, yeah, it's the range. The range is from -pi over 2 to pi over 2, or -90 to 90. Which means in inverse cosine, the range is from 0 to pi. So it will give you exactly the angle you need. Inverse sine could possibly be reference angle because it's not the entire range of angles that a triangle could have. I don't know. Does that, you guys with me on that? Anyway, that's come up before. But like you pointed out, if I do 180 minus 29.7, you get whatever the hell you just said, 150.3. Is that right?
Yeah.
And that, of course, can't exist alongside 42. So then you go, oh, thank God. There's only one triangle possible. So what is it we still have to figure out? Well, we can immediately get what? We got angle B now. We can immediately, without work, get what?
Angle C.
Angle C. I like it. So if that's 29.7, that's 42. You add them up, you get 71.7. 180 minus 71.7. It's 108.3, is that right?
Yes.
Holy shit. Part of my brain is functioning. It's amazing. All right, let me make sure. Is everybody with me? The minute you get your first angle figured out from an ass situation, angle, side, side, you must stop and check to see if there's more than one triangle possible. Oh, there we go. Okay, there we go. Okay, sure. We'll do that. Somebody's asking for a problem from 9.5. Let me think. Okay, so what's the only thing I have left to figure out?
Side C.
Side C. And how am I going to figure out side C? Well, I'm going to set up that first fully known ratio, and now I can do it in relation to C, but now I know C, angle C is this big ass dude, and divided by little c, and then I can solve for little c. Is everybody okay with that? I mean, that's almost too nice to believe. And again, The situations where you cannot make a complete ratio of angle to side are the situations that law of cosines will work. They perfectly complement each other. It's too nice to believe.
I have a question.
Yes.
Will we have to find the area like we did on 10.1 and 10.2 with like those two different area equations?
So when we did the area equations, what we were trying to do was trying to prove the law of sines. Is that
Oh no,
what you're
because
worried about?
in the homework there were problems to find
Yes.
the area with the equations, and so I was wondering if that was going to be on the test.
I don't really make a big deal out of that.
Okay.
Yeah. Let me see. Somebody's, all right, before we go to 9.5, somebody's asking me, the reason that this would not work is because the other angle that is set is too big. My angle's too big, right? So this is too big. 42 and 150 is over 180. I think you meant greater than 180. Maybe that's what's throwing me off. When you said less than 180, I was like, what the hell? All right. So you're fine. You're fine. Now it makes sense. When I first read that, I'm like, wait a minute. Let's go back to 9.5. Oh, shit. I got a whole other triangle to do. All right. Let me see. I don't have enough on this paper yet. So let's just really see what I can do here. So for this problem, what can you immediately tell with before you even draw the triangle? Will I be able to use law of sines? Nope. Nope. Even before I make the triangle. So so here's A is 6.3, B is 9, C is going to be the angle between them because this will be B, this will be A, and this will be 105. Again, with the small ass triangle, Jeff. I swear to God. Okay. So like we said, this is law of cosines. This is a classic law of cosines where you have side, angle, side. That's classic cosines. And the nice thing is that I did for you is I made this the traditional kind of related to Pythagorean theorem. But remember, the generalization to Pythagorean theorem doesn't give a shit which side is C, A, or B, right? Okay. So this will be minus 2AB cosine of the included angle. And now we just throw in everything we know. We know A, we know B. So we know A and B. Cosine of, what was it again? 105. Dadgummit. All right, that's not too bad. And you just throw all that in the calculator and take a square root. And obviously you throw out the negative possibility because it's a side length. Is everybody all right out there? So these are such beautiful little equations. You just have to know what to look for to know which equation to use when. And then you just use it. You just plug shit in and go to town. Let me know when somebody gets an answer.
I got about 12.2.
Yeah, I'll go even further. I can't remember what it said. I didn't say anything, did I? So let's round to the 100th place. 12.25. Why does that make sense with what I know about this triangle? Why does that already make sense?
Because it's such a large angle that the side is going to have to be the longest.
Beautiful. The other two are definitely going to be smaller than 105. So that side must be the biggest. It's across from the biggest mouth. I love it. I love it. And now we have to figure out the angles. And what can I use to figure out the angles now?
Law of sines.
Law of sines. And why am I not worried about the inverse bullshit? Because one angle is 105. There's only one answer possible going into this. So anytime you start with the law of cosines, you will get one triangle. That is so nice. Okay. Let's see. Do I have any more room? No. That's all right, Jeff. You can do it. Sine of 105 over 12.25 equals, and it doesn't really matter. I'm going to use the one with less decimals in it. Because once I get that, I can get the other one just, because they all add to 180. So now I can do my little thing where I do inverse sine of 9 times sine of 105 divided by, this is really gross. I am so sorry, but oh well. Right, multiply the 9 up and then take an inverse sine. So you can throw it all in the calculator all at once. Yeah, and I get angle B, I get to be. So anybody else get what that is?
45.2.
I like it. 2, 1, I like it. And then angle A, you just add those up. And what is that? 150.21. So it's going to be 29.79. Depending on how much you round it. I think that's right. That's always nice. When the last thing figure has an angle, it's the easiest thing in the world. Thank the gourd. Thank the gourds. Yeah, thank the gourds. The watermelons and the pumpkins and the watermelon and a gourd. I'm probably wrong. I have no idea. Pumpkin and squash. Jeff. All right. All right. So let's see. What was I going to do? Oh, yeah, somebody asked about section 9.5. So these kind of problems up here. And the nice thing is, or do I even have that on here? Why don't I have that on here? Well, that sucks, Jeff. What a sucky practice quiz. All right. Well, for some reason, I completely forgot that section 9.5 is going to be on this next quiz. So it's a good, timely question to ask to do an example like 9.5, because that's going to be on this also. Sorry, guys. Where's anybody still copying down here? Has everybody got that stuff? Yeah, we're going to do that right now. Somebody had, yeah, we're going to do that right now. So let's see. Let's take something right out of the book. Let me stop sharing this. Oh, I got to highlight myself. It's all about me. All right, so let me see. Let's do something out of the book. All right, 9.5. And just to remind you guys, well, I'm not even going to remind you guys. Just remember the discussion we had about the homework. Make it your own, get ready, all that kind of stuff, right? Sacrifice doing every problem for getting ready. That's the shorthand way to say everything I said before. So let's see, let's try one of these problems out. Any of these look striking to you, or anybody have any specific ones you want to try in this section before I just pick one out myself? These look gross. These look easy.
How about 24?
24, and somebody else said 33. There you go. There's the two we're going to do. All right, let's see. 24. So what's the immediate thing that should strike you on number 24? Striker, striker, striker. Anything strike you guys on number 24? It's equal to 0. Good old algebra tells you to look for what on this side? Good old algebra.
You can pull out the tangent.
Yeah. Can factor out a tangent. When something's equal to 0, your brain should kind of go, I'm not saying it's always going to be a factor problem, but your brain should go to factoring problem. I see too many people dividing by tangent. Stop doing that. You cannot divide by a piece that has your variable in it, because then you're losing solutions. You're dividing by something that could be 0, which is not legal. So don't do it. Okay, don't want to turn you in. And now that you've done this, you can do the same old thing we've done in algebra forever. You set each piece equal to 0. Right? And then this is specifically on 0 to 2 pi. So what angle makes tangent 0? What angles? What's on top of tangent?
Sine.
Sine. So tangent 0 when sine 0. When is sine 0?
0 and pi.
Yes. Do you guys understand? You don't memorize more than you have to. All right. So if you're smart about things, there's less to memorize. So this one will be sine x, subtract 1 divided by 2. So when is sine equal to 1/2? Positive, so it'll be up here.
Pi over 6.
Pi over 6. I like it. Or
Is that
Pi over 6.
yeah, that'll be another reference angle possibility. There's all the answers.
So for which problems do you have to put the like plus or minus 2k pi?
That's a very, let me see if they even, it's funny that they talk about it and hold on, let me see. Hold on, let me, wait a second. Is anybody still copying this down? Okay, I'm going to clear all this away. Here it goes. Let's see real quick. Solve exactly on the interval, solve on the interval, solve exactly on the interval, solve exactly on the interval. Oh, here we go. Determine all solutions of the trig equation exactly. That's a very strange one to be asking you to do that. But this is one where you have to figure out all solutions, plus or minus whatever, right? 2 pi k, whatever it takes. They didn't give you enough of those though. So I'll show you another place where I've suggested that you should do that. And that's on these kind of problems, where the inside is more than just an angle. It's twice or 3 times an angle. What was it? Oh yeah, somebody said 33, right? Oh, 33 we've looked at. 33 is just dumb. It's gross. It's just your answer is going to be inverse sine of blah, blah, blah. It's not very interesting. Sorry. What about this one? Does anyone want to do that one? It doesn't matter because we're going to do it. Here we go. What at this point you should know what your motivation is on this and why. Right? They're both cosine, which seems nice, but what's wrong?
Can you use the half angle formula on cosine 6x?
Yeah, double angle formula. I'm with you. So yeah, let's look at cosine of 6x. That would be cosine of twice 3x. So what's cosine of 2 theta? How can you rewrite that? I'll get us started. Get out of there, 2. Which leads to this, which leads to this. So to be honest, this is exactly how I have it memorized. I memorize this, and then I build this and I build this. And you're all like, good for you, Jeff. I know. Which one of these is the smarter thing to use, considering we have to solve this? Why was it nice in the first place? Because they're both cosine. Do I want to bring sines into this and mess up all my nice, happy asshole cosine? No, I want to. So not this one, not this. I want this one, the one that's the only one that's got the only cosine, right? Do you guys see the motivation? See why I am doing that? I have 3 possibilities. I'm going to pick the smartest one. So what is theta then in this problem? Considering this is the identity for 2 theta.
Is it 3?
3 what?
X.
X. So I can rewrite this as twice cosine squared of angle minus cosine of same angle equals 0. Oops, I left out my 1. I'll put my minus 1 at the end, which if I would have thought about it, I could have pretended like I meant to do that. Because now it's in order. When you look at this, do you guys not immediately see quadratic? Right? This is just like 2x squared minus x minus 1. Same exact thing where x is cosine of 3x. Right? So can I factor this? Oh shit, yeah. To this, put a little thingamajig there, Jeff. And I know this is 1, and I know this is 1. And then I can just figure out, all right, I need this to be a minus in the middle. So if I make this minus and this plus, that makes this -2 plus 1 makes it -1. Yay! All right, let me stop. So do you start to understand why some identities only have one possible rewrite? This identity sucks because there's 3 possible rewrites. You have to know why one of them makes more sense. And now what can I do? Now I can say cosine of this. Is this cool? Set this equal to 0, subtract 1, divide by 2. Or cosine of this equals 1. So what angle makes this true? Dadgummit, become a normal 3. Screw it, that's a 3. What cosine of what is -1/f? See the little picture I just drew myself? Because I know x is negative back here, so I know the angle's got to be here and here.
2 pi over 3.
2 pi over 3.
And 4 pi over 3.
And 4 pi over 3. I like it. Plus or minus 2 pi k. 2 pi k. Right? And what angle makes cosine 1?
0 and pi.
Pi makes it what?
Oh, -1.
Yeah. So this would be 0 plus or minus 2 pi k. Let me stop for a minute. The reason I do this, and I've talked about this before, even though the problem says find the solutions on this interval, it's so much easier to construct the answers. So now what do? I divide by 3. Divide by 3. So I get x is 2 pi k over 3. And now I can just make k, plus or minus, who cares? I want to be from 0 to 2 pi k. I can make it 0, 1, 2, and I keep going until the next step would put it over 2 pi. So it could be 0. If k is 1, it's 2 pi over 3. If k is 2, it's 4 pi over 3. If k is 3, it's 6 pi over 3, which is 2 pi, so I stop. Right? And then I can do the same thing over here. This is just going to be, let me try this guy first. Divide by 3, divide by 3, divide by 3. X is 4 pi over 9 plus 2 pi k over 3. And I do the same thing. I make k 0, I make k 1, I make k 2 until I get to 2 pi. I'm not even going to finish the problem. I'm done. I'm tired. Do you guys get that's the kind of problem, even though it doesn't say to do it, I would do it. It makes it so much easier to collect all the answers. Because then I'm just making k 0, 1, 2, 3 until, oh shit, I'm over 2 pi. Let me erase that one and go to the next thing. It makes it so much simpler. Okay. All right. Let me clear all that. Anybody still copying down? Or are you guys just looking at it? It's probably a better idea. It's just to look at it. All right, this is going to go away. All right. Bye stuff. So let's get back. I think I'm up to date here. I think that's it for questions. We got to get back into where we left off here. Let's see. So we left off in parametric equations. And in fact, let me do this. All right. Like, do what you want to, man. You're in control. I know. So I just put up here something new. I put up here something called blank graphs for parametric, but they're really just freaking, come on, plop. XY graph. Yeah, so who cares, right? Because that's what parametric's all about. Get out of here. Go away. Crappity, dude. Really? Gotta go all the way back. Hello, Canvas. All right, here we go. So here's a new thing, parametric equations. All right, so here it is. So if you want to go into Canvas right now and look at this bad boy, I'm going to pull it up a different way so I can write on it. Where did I put it? Here it is. Yay. All right. That was quicker than normal. I appreciate that. All right. So let's take a look at this. Let's do this. So if you missed last Thursday's class, I think I did a decent job of explaining with an Etch-a-Sketch the idea behind a variable behind the scenes, what we actually call a parameter, because the real variables, the ones that show up on the graph, are X and Y. T is officially called a parameter. It's behind the scenes. It's controlling both of the variables. So when we graph it, we will not see a T axis anywhere. That is a little bit freaky, but it's really flippin' cool. So let's see how this works. Notice that T goes from -4 to 4, right? So let's see if this is enough. If I can go by steps of 1, let's see if that gives me enough detail. So when I put a -4 in, can you take a minute? So all I'm doing, so this is gonna, the T column is not gonna have a damn thing to do with the graph. It's gonna be creating the points. So what normally happened in the past? I would pick a value for X, it would make an output Y, that's the point. Now I pick an input of T, and that creates both the X and Y pieces. Very freaky, very cool. So what do you get when you put a -4 in here? You will get -4 divided by 2 is -2. What's sine of -2 pi? Does sine like it there?
No.
Sine, no, it hates it there. It's 0. And of course, if I plug a -4 in here, what do I get? I'll get 16 divided by 2 is 8 minus 4 is 4. Is everybody with me? It's not that big of a step away from what we've done in the past, but it actually gives us a lot more flexibility. So let's try steps of 1. Let's see if this will be enough resolution. What do I get if I put a -3 in here? It'll be -3 pi over 2. Now that's a very interesting angle. Where's -3 pi over 2? Is everybody with me? Just put a -3 in for T. Aw, Jeff. All right, guys. Give me a second. Old man Jeff can't remember which frickin' application. Everybody just hold on. Sorry. Let's use the right thing, Jeff, and then you'll be able to move around. Isn't that going to be neat? All right, let me just give myself some shit. I'll catch right back up to you guys. Okay. So -3. If I put a -3 in, -3 pi over 2 will be there. And what sign think about here?
1.
Yes. And so I'll get 1 times 4. I'll get a full 4 there. And if I play a -3 in here, I'll get 9/2 minus 4 is 1/2, I think. Somebody can check me on that. And so it's just plugging shit in. It really is just plugging shit in, but it's just this behind the scenes dude. So let's kind of quickly, I'm going to kind of quickly go through this. -2 will be -pi, that's 0 again. I'm thinking this might not be enough resolution. I don't know if you guys understand what I mean when I say that. -2 squared is 4 divided by 2 is 2 minus 4 is -2. Right, then -1. If you put -1 in here, that'll be -pi over 2, which will be -1, so I'll get -4. -1 squared, there'll be, you can do it, Jeff. 1/2 minus 4, which is -7/2. Is that right? I don't know if you guys trust me. Yes? Okay. And then 0, that's 0 again. And this is -4. I liked 0. That was fun. And then if I make t1, remember t follows these restrictions here, right? So if I make t1 pi over 2, that's 1 times 4 is 4. 1/2 of 1 minus 4. You could do it, Jeff. Can you do it, Jeff? I don't really know if you can do it, Jeff. Yeah, negative 7/2. Notice that this is parabolic. And we've actually already passed. So it's just going to start going back up. Do you guys see that? In values. So 2 divided 2 is the sine of pi is 0 again. And 2 will just get me back to negative 2. Right? So if 2 minus 4 divided by 2 is 2 minus 4 is negative 2. 3 sine of 3 pi over 2 is negative 1. So that's negative 4. And when I put a 3 in here, I'm just going to be back at 1/2. Right? I'm building back up on my parabola. And then when I put a 4 in, I'll bet you anything I'll get a 0. That seems to be the pattern that I should have noticed earlier, but oh well, you guys probably noticed that earlier than I did. And now I'm back up to 4 here, and if you don't trust me, you could put a 4 in and see. All right, so that's not hard. That just took a while. And if I want you fast, I don't care. It's just plugging shit in. You can do it. Now comes the part where we actually graph these things, right? And as you graph them, you want to keep track of how you're moving between the points. That's definitely a new thing also. I'm curious, well, let's see. This might not be enough resolution, but we've done plenty of points. I don't know. 0, 4. And then it goes to 4, 1/2. I don't know how it moves along here, though. So that kind of sucks. Oh, you can't see what I'm doing. I don't know how it moves between these two. Do you guys understand what I'm saying? It's definitely not going to be a straight line between the two. So let's do this. We might not have to do this a lot. I really want you to understand why I'm about to do what I'm about to do. I'm going to calculate what negative 3.5 is. Something in between these two, right? So you guys are going to help me out. So what do we get if I put negative 3.5 as t? X will be 4 times sine of negative 3.5 pi divided by 2. Somebody help me out. Here, I can do it too. Make sure that you're in radians. Why am I doing this point? Because I'm not sure how these points are connected. I know it's not a straight line. I just want to get a little more detail. So I get 2.83 for this. Jeff, it's just the number 8. There you go, buddy. Oh, Jeebus. All right. Math teacher can't make the number 8. That's good. And then if you put negative 3.5 in here, 0.5 times 3.5 squared minus 4, I get 2.125. So let's see where that is approximately. 2.83. Oh, let me do that with this. 2.83 is right there. 2.125. Oh, shit. I didn't mean to write that. Sorry. Go away. 2.83, 2.125 is just above there. So it's going to be right about there. Pop. So it looks like it's going to be an upward kind of curve. Shit and a half. Well, crappity doodah. Let's try that again, Jeff. All right. You can do this, buddy. Not with the eraser. All right. All right. This is, oh, God, this is, all right. That's disgusting, but I'm not going to do it again. All right. Screw it. Thanks. I don't blame you. Feel free to laugh. It's fine. By the way, I've never shown you this. Oh, I've got my Jupyter turned on, so I couldn't even show you. Screw it. Doesn't matter. I got a cool little device that I use to. There we go. But it's not. It's a little weird how it's got to be situated. Let's keep going. 0, negative 2. Down there. And then it goes, is everybody with me? This is the hard part. This is where you got to keep your eyes on the right stuff. And then it goes negative 4, negative 7/2. Negative 4, negative 7. So negative 4, negative 3.5. I believe that's correct. right? So let me put little arrows in what's going on here, right? So I believe it should probably go like that. Let's see, before I try to draw, let me see where the next point is going. Where am I? Here I am, 0, -4. So it should probably go like this. So I got kind of a feel for the curvature of this thing here. So I don't have to be so precise anymore. We're going to graph this on the graphing calculator. I'll show you how to do it in the graphing calculator in a minute. So I graphed this one. Now let's graph 4, -7/2. So now I'm at 4, -3.5. So I'm right there. Beautifully symmetric there. And then I come back to 0, -2. Do you see how it passes through this point again? That's kind of neat. Well, shit and a half if I make it really big, maybe. -4, 1/2. So now I'm at -4. Isn't this looking cool? -4, 1/2. You don't really have to agree with me, I guess. So now I'm there. And then I come back to 0, 4 up there. Neato. What's your immediate feeling of what that looks like? Besides shit. You don't have to say that answer. Anybody?
I have a question.
Yes.
So when you're making these types of equations, do you have to draw the line between points in the order of the t-value?
Yes.
Okay.
That is the implicit t-axis in a way. Because otherwise, because you are understanding that there are an infinite number of t-values between -4 and -3. And they are going to go lockstep between this point and this point. So you can't just connect the points any order you want to, because then you're not following what the actual values are doing.
All right.
Does that make sense?
Mm-hmm.
Okay. Now, I don't think I showed you this last time, did I? Do you know how to do this in your calculator?
No,
pull
you
my-
didn't show us.
Yeah, I'm an asshole. I know. Let me show it to you now. Let me see. I am an asshole. Here it goes. All right. We stop sharing this. Has everybody got what they want from this thing? More than you wanted? Oh my gosh. All right, calculator, cooperate. All right, you guys got this. Do you guys understand the work required here is minimal compared to some of the stuff we've done before this, right? This one is kind of a rough one to start with, but I don't care. I like it because it comes out with kind of a very nifty image that we would never have created ever without these parametric type equations. This can't be done with polar equations very easily at all either. So parametric is yet another way to create more shapes. So let me share my calculator. No, Jeff. There you go, buddy. All right, let me clear this. Let me go to mode, and remarkably enough, the very first step I should take is to go to parametric mode. So hit mode, parametric. So now if you go to y equals, let me take this stuff out of here. It's playing around with this stuff. There we go. Oh, let me get this sheet up so I can remember what it is. All right, so now next one, you put their for sine, where do you go? Pi t divided by 2. So that's what x is. And then y is 1/2 t squared minus 4. Is everybody with me? Before I hit graph, I need to control t. So let me go to window, and I can control t right here. So I can make t go from -4 to 4. That's amazing. No, Jeff, not natural log, buddy. You almost hit it. There you go, man. I got my t step. Do you guys, if anybody playing along with me, your t step probably says point, I don't even know what yours says. What is your, anybody tell me what yours says here?
139, blah, 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 blah.
Oh, okay. Depending on your calculation ability, I would make it at least 0.05. That just gives us more resolution. And I'm going to make this have the same scale that it did. So from -5 to 5, right? That's the scale on our paper. And then from -5 to 5, I must have been doing some really funky shit here. Some weird ass scale. Everybody with me on that? I'm going to make it the same scale as the graph on our paper. So now if I just hit graph, look at that. Look at that. I mean, come on. Come on. Sorry, it's a thing of beauty. So to me, it looks like a giant goldfish coming up like its jaws. Right, that's probably just me. I understand. You guys okay out there? I mean, so now this is yet another place you could just play around and put all kinds of shit here and just see what it does. It's crazy. And by the way, let's see. What if I make this go from -6 to 6? What happens if I go make my boundaries bigger? Look what it does. It looks like it's going to continue. Let me make my window. Let me make my Y max go up to 50. And let's make T go -14 to 14. Well, screw you. Negative, there it is. 14 to 14. Yeah, it just keeps doing that same. Look at that. Isn't that cool? Isn't that cool? Sorry. All right, that's enough. I'm sorry. All right, so you guys try number 2. Number 2, I swear, is much simpler than number 1. That's why I did number 1 with you. What time is it? This will be the last thing we do today, I think. Yeah, okay. By the way, real quick, I'm sorry. Before you get too deep into that, I really want to point this out. Do you see how the x values are related to a sine function? What's the biggest x value that's used here? What's the furthest it goes on the x-axis?
Are you trying to show us something?
Oh, shit, I am.
I think it's 4.
I love you. I love you guys. I'm trying to show you this. I'm sorry. Let me try this again.
Okay.
I really love this online thing. What's the largest x is in this picture?
4.
4. And what's the smallest?
-4.
If you look at it like this, doesn't it look like a sine wave that somebody smushed? Isn't it basic? Isn't that what that says? As x does this, y does this shit, right? Which is parabolic. So y, that's why this is the lowest thing. In fact, what's the lowest point on this parabola? It's going to be freaking -4. Let me just dump you. And is that the lowest y goes? And it goes up on both sides equally from there. That's why this thing has symmetry the way it does. So as the x values follow a sine wave, the y values follow a parabola. And you see those working together in this picture. That is so trippy. So some of the coolest parametric stuff has periodic functions in it, of which trig functions are a very basic example of periodic functions. This one is not going to be as cool, but you know, oh well. So keep going, number 2. I'm sorry. Less cool normally means not as hard, so it's not a bad trade-off, I guess. What is that? Is that right? I think so. It's trying to be a negative. So that's 0 again. That's neat. I forgot what I even did. That's funny. So sometimes I would do this for myself, like I did up here. Put the little parentheses, so when I look at it, I know to look at this as a point, and this is not a piece of it, because it's so easy for your eyes to include the wrong thing. But no, Jeff, try again, buddy. So do you see how the x is a polynomial? So you pretty much know it's going to be curved like this, maybe. Put your little arrows to show that this is the direction that it's going, thinking that t is like time. So you guys are getting this little serpentine. All right. And then let's see real quick. If we put it into the calculator, let's double check our work here. And then we'll call it a day. Oops, shit. Let's put it in the calculator correctly, Jeff. That would be really nice. Passive aggressive much, Jeff? Yeah. I'm not going insane. All right, so then you want to change the t from -1 to 3. And let me change this back to be the same scale as on my paper. Oh shit, I'm not even sharing this yet, am I? God, I'm really doing fantastically tonight. All right, so there it is. There's our good old S, looks like graffiti S. And if you look at it like this, there's your cubic, right? The y values are linearly increasing, which is interesting, which means it's not going to mess with the x picture much. What the x is kind of graphing out. The y's are increasing linearly. I have no idea if what I'm saying makes any sense. It gets a little more interesting when the y's or the x's or both of them are going back and forth periodic. That's where really, really strange things can happen. Okay, I like it. All right, guys. That is officially section 10.7, I think, is the one that deals with parametric graphs. Yes. So tomorrow we will be finishing out chapter 10 and maybe doing a little baby step into chapter 11. So yeah, again, the jokes are all for me. So if you get something out of them, that's just like bonus. All right, so it's officially over. Let me know if you need to hang out if you have any questions.
Thank you.
Thank you.
Thank you.
Hey guys, see you. Thanks for coming. All right, I'm out here.